Okay, so you may have started learning about limits and the epsilon-delta definition of a limit. Today, I want to cover that and maybe help you visualize it. So, let's just start with the actual definition. For every epsilon greater than 0, there exists a delta greater than 0, such that if 0 is less than the absolute value of x minus a, which is less than delta, then the absolute value of f of x minus L is less than epsilon. So let's get into what this means. So for every epsilon greater than 0, epsilon can't be less than 0, right? There exists a delta greater than 0. So delta also can't be less than or equal to 0. Such that if it's 0, so that we have 0 here, this just means that x cannot equal a, right? And we'll get into more what the x and the a mean, but let's just realize that for now. The absolute value means the distance of x and a. So this means the distance of x and a cannot be greater than or equal to delta. Then the distance of f of x and L cannot be greater than or equal to epsilon, right? So a more easy way to comprehend this is if x is within epsilon of a, then f of x is within epsilon of L. So let's draw out a graph. So let's say we have a graph and we have a point A, right? Then let's find our point L. We have a point A and we have a point L, okay? Then let's find, or not find, but let's pick a delta, all right? So over here is going to be a minus delta. So this is the a value minus some small number delta. Delta and epsilon are just small numbers, all right? Then we have a plus delta. Now, let's draw these up. And let's pick a new color. Let's pick green. So, draw this over here. This is going to be L plus epsilon. And over here is L minus epsilon. Alright? So, let's shade these in. I think it'll make it a little bit easier to understand. Now, if I shade these in, let's take a look at what the not formal definition means. If an x value, if x is within delta of a, then f of x is within epsilon of L. So if x is within delta of a, that means x has to be somewhere in here, all right? That means x cannot be out here. Then if an x is within here, then an f of x must be in here, right? It's not going to be out here. You can't have an x in here and an f of x out here, all right? So that's a way to understand the informal bit, but let's look at the actual definition again. For every epsilon greater than 0. So our epsilon is not 0, because if we so that means the epsilon's not going to be equal to 0. There exists a delta greater than 0, so the delta is also not less than or equal to 0, such that if it's 0, all right, x cannot equal a. What does that mean? Whatever we pick in here, it can't be the actual a point. And why is this? Because if we have an undefined point here, right, if our x equals a would be undefined, but our lim, as x approaches a, is still going to be equal to L, right? Then the f of x minus L, so the distance in here is less than epsilon, so it's still within here. Now, the way to think about this, as this shrinks and it gets smaller and closer to A, the interval in here is going to shrink and it's going to get smaller. As it approaches A, right? We are approaching A, then it's going to get closer and closer to L. even though in this case, L is not defined, our limit still equals L. Hopefully this clarified something for you. If there's any more thing you want me to add, or you notice anything wrong with my explanation, please do comment below. Thank you.